There are two different concepts of the fourth dimension. One of them is the four-dimensional spacetime of Minkowski. In this concept, time acts as the fourth dimension. But in this video we will talk about a completely different concept of the fourth dimension, about geometric four-dimensional Euclidean space.
Geometric four-dimensional space is a space in which there are four dimensions: length, width, height, and another fourth dimension without a name. This dimension does not exist in the three-dimensional space in which we live. Zero-dimensional space is a point. In zero-dimensional space there is no size, no direction, and no sides to rotate. From zero-dimensional points, a one-dimensional line can be constructed. In one-dimensional space, a dimension and one direction appear. However, there are still no sides for rotation. A two-dimensional square can be constructed from one-dimensional lines. A second direction appears in two-dimensional space. In addition to the two directions and size, rotation appears for the first time in two-dimensional space. Rotation in two-dimensional space is performed around a point. If you add one more direction, you can build a three-dimensional cube from two-dimensional squares. In three-dimensional space, there are already as many as three directions for rotation. The number of rotation directions is determined by the formula you see on the screen. This formula is applicable to any dimension. In three-dimensional space, the possibility of rotation around a line appears. If we add one more direction to the three-dimensional space, we get a four-dimensional space. From three-dimensional cubes we can build a four-dimensional tesseract. In four-dimensional space there are six sides of rotation. In four-dimensional space, the possibility of rotation around a plane appears, as can be seen in the example of this tesseract. In four-dimensional space, it becomes possible to lay out four mutually perpendicular lines. You can observe this in the example of the rotation of these four-dimensional axes. If we rotate a two-dimensional plane in three dimensions, we will notice that it is flat. The figure is flat because its third thickness is 0. It will be similar with three-dimensional figures in four-dimensional space. Three-dimensional figures have a fourth thickness equal to 0. Therefore, when rotating in three dimensions, three-dimensional figures will be three-dimensional, and when rotating in the fourth dimension, these same figures will be flat. A quick glance at a four-dimensional tesseract may give the impression that a small cube is inside a larger cube. In fact, all the cubes that make up the tesseract are the same size. The cube that appears smaller only appears smaller because of perspective. In reality, it is not inside the larger cube, but far away in an additional spatial dimension. For comparison, if we rotate the pseudotesseract, then we will notice that it really does have a small cube inside a large cube, and that it itself is three-dimensional. You can also distinguish a true tesseract from a pseudo-tesseract by using an orthographic projection. In a true tesseract, all squares and lines are the same size. If we apply an orthographic projection to the pseudo-tesseract, then we notice that the small cube still remains inside the large cube. The coordinates of points in four-dimensional space have four values. Let's change the fourth value. In four-dimensional space, it is possible to create geometric figures unique to the fourth dimension. For example, the Clifford torus has two holes and is a symmetrical figure in four-dimensional space. At the base of a four-dimensional cylinder, which is sometimes called a spherender, lies not a two-dimensional circle, but a three-dimensional sphere. We see it when rotating this figure. At the base of the four-dimensional pyramid lies a three-dimensional cube. This program has more than 80 basic figures from different dimensions: 3D, 4D, 5D, and higher. And also in this program you can model your own figures in any dimensions. The program is called Ford and Modeling Explorer. You can buy it on Steam.
There is also a free analog for Android with the name on the screen. It has the same basic figures as the main program, but there is no ability to model. Thank you for your attention.